Supervolcanoes are one of the most feared geological events in history. And while they don't erupt very often, their impact on the entire planet is severe. So it makes sense that we want to know more about them. But there's something that we haven't talked about when it comes to supervolcanoes, something that could change everything we think we know about these massive explosions. And today I'm going to tell you the truth about supervolcanoes, even if it scares you. If you have any interest in science or tech stories, then make sure to subscribe so you never miss an upload. Okay, so let's talk about what a supervolcano actually is before I drop this huge truth bomb. We all know that volcanoes can be dangerous. They blow stuff up, and sometimes that stuff kills people. But the way that volcanoes work is pretty neat. Volcanoes happen when rock deep inside the earth melts and creates magma. That molten rock is less dense than the surrounding solid rock, so it rises up toward the surface. As it moves up, the pressure on the magma decreases, which causes dissolved gases in the magma to come out of solution and form bubbles. These bubbles make the magma more buoyant, causing it to rise faster. Eventually, the pressure is low enough and the gas is abundant enough that the magma erupts onto the surface as lava, ash, and gases. When we describe a volcano as active, we mean that it has erupted in the past 10,000 years. But the geologic record shows that most volcanoes don't erupt at the same rate. Instead, they alternate between periods of high activity with frequent eruptions and periods of quiet with no eruptions at all. Some volcanoes stay quiet for hundreds of thousands of years. The reason why some volcanoes have periods of dormancy is because the source of heat that keeps the rock below them molten can turn off. When that happens, the magma chamber below the volcano solidifies and the volcano is dormant. If enough magma makes it to the surface, the solidified chamber can even form a dome above the vent. That dome is called a volcanic neck, and it's made of the same material as the rest of the volcano, but it's harder because it cooled down faster. Sometimes erosion wears these volcanic necks down so much that they become the highest point in an area. They can even look like normal mountains. Mount Denali, also known as Mount McKinley, is the highest peak in North America. And while we used to think it was just a regular mountain, we now know that it's actually an eroded volcanic neck. So you might be wondering, how big do volcanoes have to be considered supervolcanoes? Well, it depends on how much magma they blow at once. To be considered a supervolcano, 95% of the magma needs to erupt in a single event, which is called a caldera-forming eruption. To qualify, the eruption must also have a volcanic explosivity index, or VEI, of 8. For reference, the largest volcano in our solar system that hasn't been a caldera-forming eruption in the past million years is Mount Pinatubo, which had a VEI of 6. The last volcano to have a caldera-forming eruption was Mount Toba in Indonesia about 74,000 years ago. That eruption had a VEI of 8 and ejected 2,800 cubic kilometers of ash and pumice. That's over 1,000 times larger than the Mount Pinatubo eruption. But even though these events are rare, their effects are devastating. The immediate area around the volcano is buried in ash and pumice. Pyroclastic flows race down the sides of the volcano at speeds of up to 100 miles per hour. Hot winds from the explosion incinerate anything in their path, and heavy ash falls cause buildings to collapse and suffocate livestock. People who survive the initial eruption die from ash inhalation and contaminated water. But that's not where the damage stops. Supervolcanic eruptions send fine ash particles into the atmosphere, which block sunlight and cause global temperatures to drop. Plants die, and food shortages force animals to migrate or starve. Humans need to migrate to areas that still have food or face starvation. Even after the worst of the eruption is over, the world is forever changed. One of the biggest misconceptions about supervolcanoes is that they always look like Mount St. Noggins. In reality, scientists can only identify them after an eruption because the magma chambers that feed them are usually hidden deep underground. A great example of a magma chamber that isn't visible on the surface is Yellowstone's. The magma chamber beneath Yellowstone is about 43 by 29 miles and reaches depths of 6.2 miles. It's so deep that even the tallest mountain on Earth would only reach 1/3 of its length if it were placed on top. But there are still ways to spot potential supervolcanoes without seeing their magma chambers. Scientists can look for evidence of past eruptions that had a VEI of 8. They can also look for signs that the crust is slowly bulging upward. That's because new magma is pushing up on the crust, and if it gets to be too much, the crust could rupture and cause a large eruption. Finally, scientists can monitor seismic activity to see if magma is rising to the surface. But even if we can predict when a supervolcano will erupt, evacuating the area is easier said than done. The hardest part of predicting the impact of a supervolcanic eruption is figuring out how far the ash and other debris will travel. Ash falls heaviest near the volcano, but it doesn't stop falling until it hits a mountain range or large body of water. The farther away from the volcano you go, the thinner each layer of ash becomes. Since ash is so damaging to people, structures and crops, scientists want to know how far the ash travels so that they can evacuate affected areas before the ash falls. But this is hard to predict because different particle sizes fall to the ground at different rates. Also, wind speed and direction play a major role in determining how far the ash spreads. While scientists can use computer models to predict how far the ash will travel, those predictions aren't always correct. And here's why. See, predicting the fallout from a supervolcanic eruption is kind of like predicting the weather, except way more complicated. There are just so many factors at play that can change the outcome. And in this case, the outcome means life or death for millions of people. So even though scientists can make pretty good predictions, it's impossible to know for sure. Okay, so here's the truth about supervolcanoes that could change everything we think we know about them. Some scientists think that supervolcanoes don't exist. I know that sounds crazy, but hear me out. One group of geologists argues that supervolcanoes are really just giant calderas that formed from multiple eruptions instead of one. What they're saying is that supervolcanoes may not be as rare as we thought. These scientists found 24 giant calderas that were created by multiple eruptions in places where we wouldn't expect to find them. What's really interesting is that these calderas are in places that we wouldn't expect to find active supervolcanoes. So maybe we've been looking in the wrong places this whole time. Maybe supervolcanoes are more common than we thought. Now, it's important to note that there's still a lot of debate surrounding this theory. Some scientists agree that some supervolcanoes are actually groups of volcanoes, while others argue that a single eruption is required to define a supervolcano. But either way, this is an exciting development in geology, and it could help us better understand these massive eruptions. So we still have a lot to learn about supervolcanoes, but we do know that they're capable of some truly catastrophic damage. While there are only a few places on Earth where supervolcanic eruptions are likely to occur, the damage from those eruptions will affect the entire planet. So it's important that we continue to study them so that we can better understand the risks involved. Thank you for watching this video. If you learned something new, make sure to hit the like button. And if you haven't already, subscribe and hit the notification bell so you never miss an upload.